Two to go. Nearly there, nearly there. Well, this looks easy as well. Usually, like I was saying, questions get harder and harder, and but this actually looks quite straightforward. Cool. So diagram below shows part of a circle, and again, we love this question. This question comes up so often. Please practice it and get to know this. It's always in. It's been in every paper I've looked at so far. Yeah. So please have a look. So circle shown with a bit out of it. Okay, classic. The radius is 6.4. We know that's on the diagram, and the major arc is 31.5. So I'm going to draw that. So what that's saying is major arc AB is 35. So from here to here, so all the way around here is 31.5. Okay. Calculate the size of the reflex angle AOB. So AOB. Now AOB, they've kind of helpfully drawn it in here. Okay. But yeah, AOB could have been either the inside or the outside angle, but they've said reflex and they've drawn it in just to give you a bit of help as well. Okay. So it's that angle we're looking for. So don't forget, your acute angles are ones that are less than 90 degrees. That's your acute. Your obtuse are just bigger than 90 degrees. I just realised I'm not actually totally sure how to spell obtuse. I'm just going to rub that in. But yeah, obtuse. And then reflex ones are bigger than 180. Okay, so it's like reflex. So again, these terrible drawings and terrible spelling. So less than 90, greater than 90, 180. Okay, so but they've been helpful there. They've given you the diagram, but they could have not given you that and checked for understanding of what a reflex angle is as well. But yeah, they've not done that. So the bigger angle, and actually as well with the question, because they've given you this length in here, it's likely they want the angle corresponding to the arc length. But anyway, so calculate the size of that angle. So like I was saying before, when I do these questions, everyone should know. I was off the page, right? The circumference of a circle is pi d. Okay, everyone should know that. Now, when we start taking portions of a circle, so say we've got a quarter of a circle here. Okay, that circumference, so from here to here, okay, that is still going to be pi d, but we're going to times it by 90 over 360. Okay, i.e. a quarter. Okay, because we're looking at that angle in there, we know there should be 360 degrees, but we've only got 90 degrees in this particular shape. So we're going to do 90 degrees divided by 360. Okay, so we're kind of ratioing the circumference, if you like. Okay, so if you never knew that equation, you might just know instinctively, well, I could times that by a quarter. Yeah, I've got a quarter of a circle, so that length is going to be 1/4. Okay, but it's theta over 360, which is the equation. Okay, so we should know that the circumference of a circle is equal to pi d times theta over 360. Well, this comes to a circle, the arc length, sorry, the arc length for a corresponding angle. Okay, but I'll just call it circumference. Sorry, but no, I won't. I'll call it arc length just to be correct. Sorry. Okay, so circumference is pi d, but the arc length, yeah, I'll just get my terminology correct. Yeah, it's better. Okay. So we should be able to start filling things in. So the arc is obviously 31.5. That's our major arc round here. Okay. We know that pi is just pi. The diameter is going to be twice the radius. So the radius is 6.4. So that's going to be 12.8 times by 2, obviously. And then theta is what we're trying to find and divide by 360. So we're going to be rearranging for theta. I think I'll just rearrange it all to begin with. So how do we move 360 to the other side? Well, we're dividing it on this side, so we're going to times it on the other side. So 31.5 times 360 is going to give us pi times 12.8 times theta, and then we want to move the pi and the 12.8, don't we? So on this side, on the right side, we're timesing theta by those two. So on this side, on the left side, we'll divide by them. Okay, so 31.5 times 360 divided by pi times 12.8. So it's dividing by pi and it's dividing by 12.8. Okay, I'll just move both of them down. Okay, I always kind of think on that when I've got a divide here. I can move it upstairs on the left, so it's downstairs on the right, upstairs on the left, and then these are upstairs on the right. downstairs on the left, kind of, but that's how I think on multiplying, dividing and removing equations. But um, maybe I'm the only one. And that gives us theta, so that should just be straight into the calculators. Just have a look. Mm, Yep, so that should give me 282, and just don't forget units, which is degrees. Okay, so marks for this one, you're getting a mark for your equation. So up here you would get an equation, mark for your equation. You would get a mark for rearranging, and then you get a mark for finishing. Okay, yeah, that comes up all the time. I think this is different because it's the angle they've asked for, so it's a bit of rearranging. Usually they've asked the questions as 2 marks, and they're asking for the arc length. This is just slightly different. Okay, a little twist. And that's what I always say in these kind of questions. If you go to National 5 maths, it separates all the questions into categories, so you can just do these questions over and over again and see the kind of variations that you get. And that's why I try and talk a little bit on the side as well. I try and have a little conversation about different things, just to kind of make you see what else could come up or what else you could do. Um, but yeah, if you keep doing the different types of question, you realise there's only a few variations you can throw in. Okay, and that is a slight variation from what I've seen before. Last question. I think I'm just going to do this as a separate video. Okay, but yeah, good stuff.